Okay, I'm going to walk you through this. This is Mike Adams here, the creator of the forensic acoustic analysis of the Las Vegas shooting. In a detailed video, I was able to determine the existence of a second shooter and actually range that second shooter using the acoustic properties of the speed of sound versus the speed of the rifle rounds and the hits on pavement. Using those two numbers, you can calculate the range of the shooter if you know the cartridge they're shooting. Now, what I'm going to do here is walk you through some of the sound analysis so that I'll try to peel back the layers and give you a little more detail about how you conduct forensic audio analysis to arrive at that conclusion. So the first thing I'm going to play for you is the sound of rifle rounds hitting the pavement, and I want you to notice the very high frequency sound spectra that you will hear in this. And when I say spectra, what I'm referring to is if you were to visually map out the frequencies, you can do a spectral analysis, you would see a lot of high range frequencies in this sound. So this is rifle rounds hitting the pavement. Just listen to the high frequency sounds that are very frequently found in this audio. Now that was the sound of rifle bullets, the actual bullets hitting the pavement and shattering, and that's why it produces a lot of high frequency sounds, also because it's very close to the person recording the audio. Let me play it for you again, just to make sure you've got this sound firmly in your head here. Get a good mental grasp on what this sounds like. All right, now I'm going to play for you the rifle reports from a distant location. And these audio clips, by the way, are all taken from YouTube videos of the Las Vegas shooting. This is actually Las Vegas massacre audio. Which is why you hear screams in the background, things like that. I wish I could filter those out. I don't mean to horrify you, but it's just part of what happened. So we're using authentic audio here. But listen to the distant rifle reports that were from perhaps Mandalay Bay in this case. You'll notice that it's mostly low frequency sounds, not high frequency sounds. So what you're hearing there, if you can ignore the foreground sounds of people talking or screaming or what have you, in the distance you can hear the rumble, the low frequency sounds of the rifle reports. This is the sound that comes from the muzzle of the rifle barrel as it's firing. Listen again. Now, because the speed of sound is slower than the speed of the bullet by a long shot, the speed of sound in this case was at roughly 345 meters per second, where the bullets are traveling at about 975 meters per second when they leave the barrel, which is about 3 times the speed of sound. Because of that, the bullets actually arrive at ground zero first, before the sound of the rifle arrives. Now, I want to explain that again. The bullets hit first, and then you hear the rifle reports second. And this is why in all of the audio sequences that you hear in these videos, you'll hear rifle rounds hitting the pavement, which is the high frequency sounds, and then they stop, and then that's followed by the distant rifle reports or low frequency sounds continuing on for about a half a second after. And that's because there's about a half a second lag time. So once the bullets stop hitting the pavement, it's still another half a second that you're hearing the distant rifle reports still coming in, again, because sound travels more slowly than the rifle rounds themselves. So I'm going to play an audio for you of that. I want you to listen carefully. Listen to the rifle rounds hitting the pavement, and then when they stop, you will continue to hear for about half a second several bursts from the rifle in the distance. You'll hear about 4 or 5, I don't know, maybe it's 4 bursts, something like that. Listen carefully. I'll play it for you twice. Did you hear that? After the rifle rounds stopped hitting the pavement, you could still hear the distant reports from the muzzle or the barrel of the rifle. Listen again. Now what you're hearing and what it's proving is that, of course, the speed of sound is slower than the speed of the rifle bullets. And a lot of people make the mistake when they're trying to do an acoustic analysis of listening to the beginning of the gunfire. What you should really do is listen to the end of each firing sequence, because it's the endings that tell you the range of the shooter. And how is that possible? Well, you take the time code of the rifle rounds hitting the pavement when they end. You take that time code, we'll call it A, and then you take the time code of the rifle reports ending, we'll call that B, which might be, let's say, half a second later, and you subtract A from B. You get a time value, which could be 0.5 seconds, that time value tells you the range of the shooter. It's a simple mathematical equation at that point. I just worked it up in an Excel spreadsheet. Now, if that time code is much smaller, let's say 0.3 seconds or 0.2 seconds, that means your shooter is much, much closer. If that time code is longer, like 0.7 seconds, that means your shooter is much farther away. And you can, again, accurately calculate the distance based on that time gap. By knowing the speed of sound and knowing the muzzle velocity and the velocity curve of that bullet due to its ballistics coefficient, you can get time of flight data for those bullets at any range, and then you can calculate the range based on this acoustic analysis. This is straight up science and physics. There's nothing really complicated about this. All right, next I'm going to play an audio file of a shooter at probably Mandalay Bay. So this is what it sounds like when there's a shooter at 425 yards with a lag time of 0.559 seconds. Now, unless you have a timer or you're looking at the waveforms in software, you may not be able to detect this with the human ear. But this is what it sounds like with a shooter at 425 to, let's say, 450 yards away. Here it is. Now again, I know it's very hard to hear that, but encoded in that audio information is the ending time code of the rifle rounds hitting the pavement, as well as the ending of the last rifle report. If you subtract one from the other, you get 0.559 seconds or thereabouts. You range that based on the speed of sound and the speed of the bullets, and that tells you that shooter was at 425 yards or 450 yards. I mean, it's in that range. So that is consistent with the Mandalay Bay Hotel. That is very likely, what you just heard, those are rounds being shot by someone who was at the Mandalay Bay. We don't know what floor they were on. We don't know if it was Stephen Paddock pulling the trigger. For all we know, he might have already been dead, and somebody else was there shooting away after they shot him. I mean, this audio can't determine that, obviously, but it can determine there was a shooter at a range of 425 to 450 yards, and that's consistent with the distance of the Mandalay Bay Hotel. I'm going to play it for you one more time, just so you can hear it again. I know it's short, but this is what it sounds like when someone's shooting from 425 yards. Now I'm going to play for you audio of a shooter that was much closer, what I'm calling shooter number 2, who was probably at around 250 to 270 yards, something in that range. This shooter, if you do the calculation of the waveform lag times, you get about 0.374 seconds, which is consistent with a shooter at 250 to 260 yards, something in that range. Now, your human ear probably won't be able to hear the difference here, but if you look at the waveforms in a wave editing software and look at the time codes, it's actually very different from shooter number 1 at the Mandalay Bay. So let's listen to shooter number 2, what that sounds like. There are a lot of voices in this, but you can extract the frequencies of the rifle reports. I'm going to play it for you again because you got to listen at the end for the last rifle report to go off, even as the voices are heard in the foreground. So if you look at this closely, and if you have training in audio engineering, you know, as I do, I've done tons of music over the years, audio editing and, you know, vocals and things like that. It's very obvious when the rifle reports end here versus when the shots on the pavement end. And this lag time is about 0.374 seconds. So again, shooter number 2 here is much, much closer than shooter number 1. And if you go through all the audio files that are available on this, you can find very similar patterns. I found other lag times that were around 0.4 seconds or 0.395 seconds. And then I found a cluster of lag times that were around 0.56, 0.565, 0.545, and so on. So all of these lag times are clustering around 2 shooters. What this tells me is that there were 2 shooters, not 3, at least not in the audio files that I found, but there were definitely 2. Not 1, not 3, but 2. At least 2 different locations, we can say that. Maybe there were multiple shooters at the same distances, so that would be consistent. If there was a 3rd shooter at 250 yards, that would analyze the same as a 2nd shooter at 250 yards. All I can tell you from this is that the ranges of the shooters cluster around 2 ranges. 425 to 450 yards, and another shooter at 250 to 260, maybe 270 yards. And that's what the audio proves. Now, this is forensic evidence. And I got to ask you, why isn't the FBI conducting this kind of analysis? This is straightforward stuff. I'm just one guy. I'm just a scientist in the middle of Texas doing this essentially because I'm intrigued by the problem. I want to solve the problem. I want to, get the evidence out of the noise. Why isn't the FBI doing this? You would think that they would have people who understand maybe forensics. I'm not sure. I mean, they did have a hair lab that was totally fabricated and false, and they just faked all their hair analysis data for 20 years and threw a bunch of people in prison based on that. So I don't know. Maybe they don't actually do any forensics. I'm not sure. Maybe they just fabricate whatever they want. But if they're interested in actual forensics, then this audio contains all the data that you need. The signal is there that there is at least a second shooter. It's irrefutable. Unless you think Stephen Paddock could alter the laws of physics and change the speed of sound and make his bullets slow down and things like that, which, is absurd. So if you believe in the laws of physics and you don't think that Stephen Paddock is a magical wizard or a member of the X-Men or something, then you got to understand there's a second shooter. It's irrefutable. And it's all found in the audio. The evidence is in the audio right now. It's posted all over YouTube. I just downloaded it, did the analysis, did the math. It's irrefutable, people. There was a second shooter. We don't know exactly where he was, but we know his range. And if you draw a circle around ground zero at that range, it intersects with a few key buildings. The AM/PM rooftop, that convenience store on the north side, right? The Oasis Apartments on the southeast corner. There's a construction site with a big dirt mound just south of ground zero. Those are the three most likely places where this second shooter could have been perched, because the audio confirms that there was a second shooter at that range. So you just draw a circle and you send your agents out to all those buildings that intersect with that circle. Every building at that range should be inspected. You should look at the rooftops. You should look for expended brass. You should look for footprints. You should look for evidence. But the FBI is not interested in that, it seems, because they're not interested in evidence. And thanks to James Comey, the FBI has been known recently for basically destroying evidence, obstructing justice, conspiring with Hillary Clinton, sweeping evidence under the rug, and not prosecuting high crimes and treason in these United States. So that's pretty sad. That's pretty frustrating. And we seem to have an FBI that's interested in covering up evidence rather than actually exploring evidence, which is why I think they will ignore this forensic audio analysis. I mean, that's what I expect. I don't know. We'll see. Maybe I'm wrong. Maybe they have a new guy in charge and they're suddenly interested in law enforcement. I don't know. Maybe they've suddenly awakened to forensic science and acoustic analysis. Maybe. But I'm not betting on it. So anyway, share this everywhere. We got to get this out, folks. I posted a full video with whiteboard analysis plus the chart, the forensic analysis chart, the ballistics range chart that you can use to determine ranges of the shooter based on the lag time of the acoustics. I posted all of that in a detailed video. You can see that at shootings.news or naturalnews.com. We got to get the truth out there, folks. This is very important. Don't let them cover this up. Thanks for listening. Thank you for watching. If you want to support our mission, visit us at healthrangerstore.com for the world's largest selection of lab-verified superfood and nutritional products for healthy living. It's at healthrangerstore.com.